All right, class, welcome back. Um, this is going to be for Integrated Math 1. This is going to be kind of the last new material that we cover is Chapter 11. And what we're going to look at is the relationships between lines and angles, especially when lines are parallel or when they're not parallel or when they're perpendicular, okay? So a bunch of different properties occur, and we're going to go through some of those and then show how you can calculate angles given variables based on the way that they fall with parallel lines. Okay, so starting here, we have a group of things here. We have 4 different definitions, okay? We're going to look at this diagram here, and we're going to define which ones are the ones that correspond for each instance, okay? So alternate interior angles, okay? We're going to call these AIA after this. So alternate interior angles, so anything further in the notes will be AIA. Okay, so you can see that this diagram actually has all the alternating angles in the same color. So interior, I want you to think of this whole area as in between these 2 lines, right? And then anything out is going to be in this direction. Okay, so this is outside, right? And over here is out. Sorry, over here is out as well. Actually, we're going to erase that out. So let's look at which angles correspond in the interior. So alternate interior angles are congruent. So angle 3 is an alternate interior angle, and it's also congruent with angle 5. And then the other group is angle 2 and angle 8. You can see those are the same measure as well. So those are alternate interior angles, okay? Interior because they fall inside these 2 parallel lines. Again, this is outside here, and this should be number 6, okay? And they alternate, right? They're on the other side of this line here. So alternate exterior angles, okay? We're going to call those AEA from now on, just to abbreviate, okay? So exterior are the outside ones, right? Exterior. And we're going to look at the ones that are also congruent. So angle 4 is congruent with angle 6. And then angle 7, or angle 1, is congruent with angle 7. All right, so you have 2 sets of alternate exterior angles. Okay, so same side interior angles, we'll call these SSIA. We'll abbreviate a lot of these going forward. Those are the ones like angle 2 and angle 5, right? They're not congruent, so I'm not going to put them as congruent. Angle 3 and angle 8 are also in that group. So angle 8 and angle 3. And again, they're not congruent, so we're not going to call that. Okay, corresponding refers to ones that occur, if you think about these as 2 groups here, 1, 2, 3, 4, 5, 6, 7, 8, ones that occur in the same spot on the parallel line with the, I think this is called a transversal. Right, so angle 1 corresponds with angle 5. So these ones are congruent. Okay, so angle 1 corresponds with angle 5. And then once you see 1, you can kind of see the rest. Well, angle 2 then corresponds with angle 6. Right, so those are congruent as well. Get used to using congruent just because it's a good term that you're going to use in geometry going forward next year. So angle 4 is congruent with angle 8. And then our final one that we have here is angle 3 is congruent with angle 7. Okay, and we'll call these CA from now on, corresponding angles. So this is a really important thing to understand. So if you have to go back, go ahead and look at that again. All right, moving on. So, which angles are congruent? Well, we talked about this. We already know from last class that, or last chapter earlier on, that opposite angles are congruent, right? So there's a lot of possibilities here. I'm not going to name every one, but angle 1 is congruent with angle 3, and those are opposite angles, right? That's the one I didn't abbreviate before. Opposite angles. Okay? Then angle 1 and angle 5 are congruent, right? And there's going to be, I'm not going to cover everyone, but those are corresponding angles. See, because 1 has kind of the same position as angle 5. So those are corresponding angles. And then let's find an alternate interior angle. So if you look here, if we alternate to the other side, angle 4 is congruent to angle 6. So those are alternate interior angles. Okay, and I'm just going to abbreviate them to save time. So we found some examples, but there's definitely a lot more. Okay, moving on. So here, which angles are supplementary? Well, we remember that supplementary means we add up to 180 degrees. Okay, so once we know that, well, angle 1 plus angle 4, those are supplementary. Those equal 180. There's tons of possibilities here, right? And because we know that 3 and 4 are supplementary and 4 is congruent to 6, well then angle 3 plus angle 6 is supplementary. So that's another example because those equal 180 degrees. And then we have, let's see, there's lots of examples, right? 3 and 8 actually we could do because we know that 6 is congruent to 8. So we know that 3 plus angle 8 equals 180. When we have these parallel lines, just kind of use, common judgment too, right? Like 4 and 7, that wouldn't work because they're both acute angle. Actually, no, I'm sorry, 4 and 7 do work. But, like 6 and 4 wouldn't work because they're both acute angles, right? So let's record one more that works. Angle 4 plus angle 7. Those are also equal to 180. Right, so remember, supplementary means which ones add up to 180. Anytime you have two angles that make a straight line, or two angles that make a straight line, and then one of the angles is congruent to another, like in the case of 4 and 7, you can conclude that they add up to 180. All right, so moving along here. Okay, now this one says identify all the numbered angles that are congruent to the given angle. Well, we have a given angle here, and let's just call that angle 8 equals 51 degrees. All right, now we're going to have some that are congruent and some that are supplementary. So but it only asks for the congruent ones. So right away we can see that the opposite angle, angle 7, so let's say angle 8 is congruent to angle 7. And what else? Well, opposite interior angles here, right? Alternate interior angles, I should say. So angle 4 is also one of them. And then these are opposite angles, so angle 5 is the last one. Okay, and those all equal 51 degrees because of the properties of angles and knowing that straight lines always add up to 180. All right, so number 2, that should be pretty easy. Number 2, let's call this angle 6. Okay, so that's going to be angle 6, and we know that that's equal to 120. So we got to find the other ones that are also congruent. Okay, so corresponding angles we know are congruent, so that's going to be angle 1. So angle 6 is congruent to angle 1. And then again, we know that opposite angles are congruent, so we know that that's congruent also to angle 3, and those all equal 120 degrees. All right, should be pretty simple to see. You just want to find all the angles in that diagram that correspond with that. So, moving along, halfway through this. Okay, so here we have a diagram. We have two sets of parallel lines, right? We know they're parallel because of the arrows, right? So the little arrow on a line means parallel. Is parallel, right? That's another symbol for parallel. So because we know that, we can find a lot of things that are congruent. Okay, so first thing is that these opposite angles are congruent, right? So we have 105 and 3 are congruent, and then 3 and 8 correspond, so 8 and 105 are congruent, Okay, now we know that 1 and 8 add up to 180, so this one is just equal to 180 minus 105. So angle 1 is really equal to 75 degrees. Okay, and once we have this, we know that all these angles are either going to be 105 or 75. Okay, so let's look at angle 2. Well, angle 2 is the opposite angle of angle 1, so that's congruent, so that's 75 degrees as well. Angle 5 is congruent to this angle right here, right, our 105, because they're corresponding angles, so that one's going to be 105. So now we know that one. And we really, it's like 50-50 here. We have two options. And so once you start to see them, well, these are alternate interior angles, so those are both going to be 105. And then angle 7, well, those are those are opposite angles, so that's going to be 105. And then we see angle 8 is going to be 105 as well. Okay, so just using the properties that we know about parallel lines along with angles, this works out and it's pretty easy. All right, next one. Let's look at this. So we have to find angle 1 and 2. Well, this is pretty easy as well, right? Because we know that angle 2 equals 180. Oops, sorry. We know that angle 2 equals 180 minus 75, right? And then angle 1 is already equal to 75. So we can say angle 1 equals 75 degrees. Okay, then angle 2 is just equal to 180 minus 75. So that leaves me with 105. All right, and then these two add up to 180. So I'm already done with this one. That was pretty easy. Okay, here's a little bit more tricky, but it's not that bad. So when we look at these properties here, okay, so A and D here are going to add up to 180. All right, so once I know that, if I want to find angle D here, let's call that's actually angle 1. Let's just call it that. Angle 1, right? That's just going to be 180 minus 80. And that's pretty easy to see that that will just be 100. Okay? So that's 100 degrees. And then these are actually, if we were to extend this line here, right? Say we extended it and it was really parallel, right? And these are both parallel. Well, these are alternate interior angles. So angle 2 is congruent to this 70-degree angle, which means that angle 2 is equal to 70 degrees. All right, almost done here. 2 more slides. All right, so we looked at in the last one that if we have these interior angles that are not corresponding, but they're on the same side right here. Now this is going to add up to 180. So I'm going to set up an equation here to solve for x. Okay, so I have x minus 12 equals 180. So this is pretty easy. We've done this before, so it shouldn't be bad. So 2x plus x is equal to 3x, and then we add 12 to this is going to give us 192. All right, and once we do this, then our final step is to divide by 3, and x will equal 64, I believe. Let me double check. Yes, x is equal to 64 here. Okay, so and then this last one, 3y plus y plus 20, right? So these are going to add up to 180 as well. Notice the total, so a quadrilateral, the total of the interior angles are going to be 360. So interior angles add to 360. Okay, but each side, this is a trapezoid, right? Hopefully we all know that. Now these two add up to 180, and then these two are going to add up to 180 because these two lines are parallel. All right, so we're going to set this up, add up to 180, and subtract 20. Then we're going to combine the 3y and y, so we get 4y equals 160. Now we're going to divide by 4. Okay, and y is equal to 40. Yeah, and that's not degrees, that's just y equal to 40, right? Because we didn't, if we were to go put this in, we could find the degrees. and we would get 120 and 60 here. So that makes sense because it adds up to 180. Okay, but this is a good thing to remember, is that quadrilateral interior angles add up to 360, all four of them. Right? Okay. One more thing to cover. All right, so as we were saying in this one, we talked about quadrilaterals add up to 360. So if these two are right angles, right, those are going to be 180, and we're left with 180 here. All right, so same type of problem. Actually, let's go back. We're going to add these two together, and we're going to set them equal to 180. So that is going to give me plus 50. So we're going to have 2x is equal to 230. We're going to divide by 2. X is going to equal 115. Now this actually asks for the measure of each angle. So one of them, one angle is, we'll call this angle A. This is angle B. So angle A is just equal to 115 degrees. Right, and angle B, well, that would be 115 because that's my x minus 50, right? So x minus 50, which is really 115. 115 minus 50, and that's going to give me 65 degrees. Right, so angle B equals 65 degrees. This makes sense because they both add up to 180. Okay, last problem. So in this instance, right, we have this angle here and then this angle here. Now you can see that they're both acute angles, and because they're parallel, right, these are corresponding angles. So they're going to be equal, okay? See, corresponding angles are congruent, right? They're the same. So we're going to set them equal to each other, and then we'll solve. So 3x minus 10 equals x plus 40. You guys can see how, like, you've done a lot of these types of problem solving before. It's just recognizing how to set them up. All right, and we're going to subtract x. We're going to add 10, kind of doing two steps at once here, right? We add 10 to both sides, and then we subtract x. So when we do that, we get some things to cancel out, right? This is going to cancel out, and this is going to cancel out. So we're left with 2x equals 50. Well, that's pretty easy. We just divide by 2, and now we know that x equals 25. Now that doesn't give us our final answer. We need our angles, right? So one of them we're going to have, let's call this angle C and this angle D. Okay, so angle C is 3x minus 10. All right, so we're going to have 3 times 25 minus 10, which is 75 minus 10. And angle C is equal to 65 degrees. All right, then angle D is equal to x plus 40. And that one's a little easier, right? We're just going to put in our 25 plus 40. And it makes sense that these two would be equal. In fact, you don't even need to do this last part, right? Because we know once we get this answer for angle C, that angle C and angle D are congruent. So you wouldn't actually have to do the calculation for angle D. Okay, I went kind of fast there, but feel free to rewind, go back to parts you need. Got plenty of information there, and that should help you be able to do the homework.